Magandang umaga, calcsters. Alos Friday na. Yeah? I think so. Cool. All right. Let's dig in. So, looking at stuff. Yesterday, we looked at some trig things. We talked about the continuity of trig stuff. The last thing you guys have in your notes, and whether it's in your notes or we just talked about it, we talked about the continuity of sine and cosine, and then all the other ones have discontinuities, right? Is that in your notes? Discontinuity of cosecant and secant and tangent and cotangent? Okay, so super duper easy for today. And we're not going to hit the log stuff near as hard as I want to because I know it'll show up later and we'll hit it really hard. But let's just recall, because we all have it, the graph, or the graphs rather, of f of x equals the natural log of x, and we'll call it g of x for this situation, e to the x. Okay, you guys are going to help me sketch these graphs. And you don't have to do a ton of work with it, but we're going to look at them real quick. So I'm going to sketch this. Anything that happens in this box is optional scratch work that I need you to think about and like at least acknowledge it. But as far as writing it so that your notes are nice, as long as you're following along and like engaging with it, I'm okay with just talking anything that's in there. I'll write a bunch. You don't have to. Which one do you want to graph first? Fern. For first, what do you want to grab? Okay, interesting choice. Not what I was expecting. Who's doing the water drop, just out of curiosity? Okay, cool. It's that leaky ceiling. So, we're going to do natural log of x. And we're going to think about this, natural log of x, and I want to know what is the value that it spits out. Again, anything in this box is optional for you to write down. I only need a few points. I can't believe that you picked this, to be honest, but that's okay. Here's my challenge for you. This thing can be hard to think about, right? Natural log of x. ln, because it's natural log in French, and maybe Napier was French, and now we're circling back. Doesn't matter. ln x is log base what? So I might be thinking this whole time about log base e of x. Now, when I graph logs, and coincidentally when you graph logs, because I'm pretty sure that I'm the one that taught you how to do it, I think backward. There are some nice, easy powers that I can get to spit out, right? So, for example, if I want the easiest thing to possibly spit out here, e to what power is easy to calculate? E to the 0. And based on the definition of a log, I'd say that this thing equals f of x, right? Or y. If I want this to be 0, I need log base e of x to equal 0. That's ln of something equals 0. And now I'm goofed up time. Before we write it, let me think, because I'm trying to think of how we did this. I want to do it the same way we did it last year. Is this how we did it last year? We're going to think opposite. We're going to change it real quick. Not much is going to change about this, but I want to make sure we do it the same way. If I see if we get anything meaningful. You remember how we graphed logs last year? Okay, so I probably could have kept going and nobody would have noticed. Okay, well, we'll check it out. Alex, I'm going to abandon ship real quick. We'll come back to this. I was not expecting you to say natural log x first. Yeah, no, it's okay. It's first. Let's graph this one first, and then we'll make sense of it, because this is easier to think about for, like, everybody. So, I'm not going to erase anything there, but we're going to graph the other one, too. All right, this one's more natural. Y or g and e to the x. Give me some values. You can pick at will. 0. What's e to the 0? So check it out. I get 0, 1 on my graph. And I'm going to label this here very intentionally. Give me another value of x. 1. That's a good choice. What's e to the 1? E. Okay, so here's 1 and e. E, 1. Give me another value. Whoa, that should be 1, e. I'm backward. 2 is a natural choice, but I'm not going to pick 2. 3 is the next natural choice, but I'm not going to pick it either. -1 might be handy. Because if I plug in a -1, what's e to the -1? It's not negative e. It's 1/eth, or 1 over e. Okay, so 1 over e is like 1 over 2 point something. I don't know, it's over here somewhere. Negative 1e. Do those form a straight line? No, they shouldn't. This is an exponential function. Now, if I pick one other point, and I want you to put it, but let's do negative 50 trillion. Again, you would never plot it, right? We're never going to go that far. This would be capital T for trillion, just so you know. This is 1 over e to the 50 trillion. Are you guys cool with that? E to the 50 trillion is a huge number. 1 over a gigantic number is almost, but not quite what? Good. Is it ever going to get to 0? So we have a horizontal asymptote. So make sure that it don't cross the axis. And here it is. This is our lovely exponential graph. It might remind you of COVID times. Just wanted to bum everybody out a little bit. Okay. Earlier, Fern made a pretty big comment that I don't want Fern to answer this time. But when we had e to the ln x, they undid each other. Why? How come an exponential to a log, like, they just undid each other because they're inverses? Okay, if you give me a function and its inverse, something switches places. Like, there's this whole process for when we find inverses, we swap the variables and we solve, right? When I say we swap the variables, it means every x becomes a y and every y becomes an x. Cool with that? What do we call every x that a function can take? It's the domain. And what do we call every y? The range. So instead of just saying that, hey, the x's and the y's flipped, we could more correctly claim that the domains and range flip, right? So check it out. 0, 1 is on the graph of this. That means the flip of this is on the graph of the inverse. And since we're looking at e to the x and its inverse, what must be on the graph here? 1, 0. Now, when we look at this, and this is where I started a second ago, I know that if I want this to be e to the 0, because that's super easy to plug in, this has to be a 0. We get e to the some number equals, why am I goofed up here? Say it again. So it should be the natural, there we go, that's the question. The natural log of e, maybe? That seemed easy to plug in. And we're going to switch this. We'll come into goofy order, and then we'll refine everything. What's the natural log of e if we pick e for x? E to what power gives me e? 1. So I get the ordered pair e comma 1. So we'll go to e over here somewhere and 1. There we go. I don't know what on earth. Sorry, I'm frazzled this morning, and I don't know why. Okay. Give me another easy number to pick here. Ooh, let's try it. Don't write it. Let's try it. Natural log of negative 1 is really the question, e to what power equals negative 1? Ooh, so let's try a different one. So this doesn't work because we can never make that happen. Never. So we had a different suggestion. What if I pick 1 over e? Or 1/eth, if you will. E to what power gives me 1 over e? Negative 1. So if I go to 1/eth right here, I go down to negative 1. Bless you. Here it is. And then we need this last little part. Natural log of 1 is our nice last one. E to what power gives me 1? E to the something equals 1. 0. So I get the point 1, 0. There we go. This is 1 over e and negative 1. Okay. This graph, just like the other one, has a wonderful asymptote. And we'll try and look at that perfect, just like I meant it to be. We have our two graphs. Now, as we look at the graphs, our focus today is not in just building graphs with lots. We will, but the more important idea that we look at is the questions that we've been worrying about. Is my green function, which is in this case e to the x, is it continuous? Yeah, I can draw the whole thing without ever picking up my finger. What's the domain of that function e, the x? All real. Cool. So we're just reviewing this because if we're looking at limits, we need it to be continuous and we need it to be within the domain. What about that blue function? What's its domain? Not rhetorical. Talk with your neighbors, 15 seconds, I'm going to call to be random. 3, 2, 1. Talisha, you're hiding in your jacket. Oh, that's okay. You're yawning in your jacket. What's the domain of this blue function? Good. Positive numbers, right? Which means we need arguments to be positive, but same question follows. Is this continuous on its domain? Do I ever have to pick up my pencil here? Or finger or anything? Not unless I try to get over here, but it doesn't exist. Okay, little fun bonus algebra fact. Are these just reflections of each other? Over what? Over the line y equals x. Not the x-axis, because that would just fold it down here, but the line y equals x. Cool. So a little tiny bit of stuff. But if you know these graphs, it is going to make evaluating limits with these things easier a lot of the time. Here's our little last comment to make. We get some theorems. Cool. So we've gotten 3 nice limits already this section. There's 3 more coming right now. So theorems. And we'll just say log limits. And they won't all be logs, but they're all connected. Cool. And it turns out there's only 2 of them. So that's even easier. Okay, go with your gut and you will be right. If I ask you to take the limit as x approaches c for some exponential, the base doesn't have to be the number e. In general, we can just say it's a. If I take the limit as x goes to c of a to the power of x, what's your gut say this is? Just c? A to the c? And boom, you've got it. It works just like a polynomial function would. It's not a polynomial. It's called a transcendental function because it transcends all those regular values that we deal with, but we have it nonetheless. Okay. Harder one, but it's the exact flip of this, or the inverse. If I take the limit as x approaches c of, let's say it's log base a of x, what do you assume is going to be true about this? Log base a of c is what I heard a couple people say or state. Does that seem reasonable? It is exactly this. The only thing we have to be careful about is we have 2 restrictions. Whatever my base is right here, we want it to be big. So we're going to say a is greater than 1. Because it can't be 1, right? Like, that'd be boring. It's always 1. Okay, other thing, this value of c, we want greater than 1. If we let our base a be less than 1, it flips our function. We wind up getting a different looking thing. We'll deal with it. Okay, for the next 15 minutes, I want you to either continue working on 33 or add the following. And I'm just going to say add. We'll do it on the Google Classroom. Huh. You guys ever notice this on the Classroom? I just want to look here real quick. Jeez, it's not just the answers. It's all the odd solutions. Oh my goodness. It's like I trust your academic honesty and I just want you to have all the resources possible to make sure that you're learning as well as you can. Weird. We could look at every problem here. Interesting. Notice where I stop. Nope, we're in the wrong section here. Cool. All right. If you haven't noticed it, I just want to point out they're obviously here. Anybody notice that? Okay. Cool. What do you think SSM stands for? Mine says TSM. Solution manual. What did you say? There's no H. All right. Happy 9th of... Give me 1 second, JJ. I want you tonight to add... Well, that's not the right... There we go. 35 through 45 odd. Okay, here's the deal. I give you the odds and all the solutions. If you don't understand it, I want rather we talk about it, especially like if you check the solutions, I'm fine with that after, preferably. But if you have an answer on your page, like I don't really care about just your answer, it's the work and the thought that goes into it. If you have the right answer because of solutions, that's fine. But you got to ask about that problem so we can talk about it. Otherwise, I'm going to start giving you all the evens with no answers. Cool. Uh, AP problems. And let me see if I want all the AP problems or not. I don't remember how long this is. So you get a few little limits. Cool. And we'll go evens. So there's 11 AP problems, but I only need the evens. Cool. Baller. I'll get some tunes going. Play around with 33 for a minute. Cool. What's up? Yeah. Baller. All right. I'll have you guys get to it. I'll tell you, we're going to work 33 at the very start of class tomorrow. Don't just default to the solutions manual to get the answer. Play around with it. Cool. All the other ones I'm fine with.